All right, good morning, class. This activity for today is going to be working on vaccines and populations. So trying to understand how a vaccine can help in different circumstances and how a population, as it gets vaccinated, can start to reach something called herd immunity. So for today's activity, you're going to, on Canvas, this is the assignment page. Excuse the background noise. So this is the assignment page. When you click on this link, you're going to get led to your sign-in page. And so I'm going to sign in really quick. And as you get signed in, you're going to notice your activity coming up for one of your classes. So as you get to your page for your particular block, and remember, whenever you're signing in, if you're having trouble finding this information, remember you can always go back into this page. There's your username based on each student and your password. Remember, all of you guys, unless you've changed it within the system, have the CCP and then the block that you are in science class. So when you get to this page, you're going to, like I said, click on the Savvis Realize, sign into your account, and then you're going to see this activity pop up on your account today. All right, so at this point, I'm going to find the actual assignment, and, oops, wrong button. And at this point, you're going to, on your guys' end, it'll look a little bit different because you're going to click on the assignment. On my end, I'm just finding it within all of this. So the Interactivity, Vaccines, and Populations assignment, when you click on that, it's going to pop up a screen that looks like this. Now, just a note that a lot of times you'll have to adjust the zoom on your computer in order to make sure that this all shows up. So you should see most of the instructions. Play around with this a little bit for each computer. You should be able to see the instructions or the overview, the learning outcomes, and the investigation itself. And there's a button down here called Run that's really important, as well as these different pieces. I'm going to move that, which is showing that the blue represents an unvaccinated person, the purple represents vaccinated, and the red represents someone with measles. So the overview of this is going to be imagining that you're a doctor sent to another part of the world to stop the spread of a measles virus. Could a vaccine contain the outbreak? And in this virtual lab, you're going to explore the relationship between the percentage of a population that's infected with measles and the percentage of a population vaccinated against it. You'll be able to use the navigation buttons, the ones that I showed you, that are going to appear to the right of the investigation tab to repeat or to go back earlier parts of the investigation. Okay, so once you understand that and what the eventual goals are, let's go ahead and get started. So click on the investigation tab, and there's all these buttons up here that you'll get to access here in just a second. So first click on where it says run. And if you notice here, there's a red person who's outside of this bubble. If you imagine this bubble contains all of the people in a population, and this is someone coming from outside of that population who's infected with measles. And so we're going to watch what happens. So if one of those people comes in, if one infected person comes in contact with a population of unvaccinated or blue people, then let's see how it spreads. So you can tell that it's run the entire simulation, and at this point, since it's run the entire simulation, it has gone through, and you had all of these except for this one person were this one blue person. All of these other ones were red. Now I hit the reset button to get it back to this, but we'll go ahead and hit this one more time just to watch what happens. Let me reload this because for some reason it's not doing that. Okay, so if we let it run again, so it's spreading again through this population the same way I just showed you before. And what you have here is, if you start to count this, all the red people, or all the people inside of this bubble, you're going to get 20 people total. So out of the 20 people that are in this bubble, 1 out of the 20 did not end up getting sick. So this 1 out of 20 is what we would call, they're going to be healthy in this case. And for the other 19 out of 20, those are people who ended up getting sick. So we're going to look at, in this case, none of the individuals on the inside of here were vaccinated. In other words, these are all unvaccinated individuals against measles. And so 19 out of the 20 ended up getting sick with the measles. So up here, you can actually look at we'll look at the factors here in just a second. But this is just a good time to look at the instructions here because this is going to help you to work your way through this. So after a simulation runs, you're going to click the reset button, and then you're going to send the community back to its original settings. You're going to open this factors button after you do that and move the slider to increase the percentage of the people who have gotten the measles vaccine. Okay, and then you're going to click run again. And you're going to repeat this for each of the different vaccination percentages. And there's also this graphing button that you're going to look at as well. Okay, so I'm going to hit reset here again. And if you go up to factors, you can move this to 50% vaccinated, 80% vaccinated, 95% vaccinated. And if you look at the worksheet that you guys have been given in class, and I'll pull it up on my screen here. On this worksheet, you're asked to look at a couple of hypotheses first. What do you think is going to happen when the measles virus comes in contact with a group of people who are not vaccinated? This is going to be a question that you're going to answer before you do this first simulation, as well as what do you think is going to happen if they come in contact with vaccinated people? So once you actually get to this data and observation section, you're going to be looking at first 0% vaccination, which is what we just looked at, which was when everyone was colored blue at first in the population. And once the virus actually spread, how many people were actually infected. So if we go back to our page here. All right, so we're going to adjust this back down to 0% because remember, if you want to relook at that 0% example, you can do that. But the second one you're going to do is the second one you're going to want to look at is the 50% vaccinated. So now that we've done that, we can minimize this and hit run. Okay, so now you can see that half of the population is now purple. Okay, so there's 10 people who are now vaccinated. All right, and we're going to see how far this virus, in this case measles, spreads. You can see the button that says reset popped up, so that means that the simulation is finished running. So the one unvaccinated person, or the one infected person, outside of the population, we don't count them as a part of our numbers on the inside, but we now see that 4 people are infected with measles, and the rest of the people inside are not. 10 of those people are vaccinated. So in other words, 50% are vaccinated against measles. The other 10 were not. 4 out of the entire 20 people, okay, remember there's 20 people inside of the circle, ended up getting sick, whereas the other 16 people did not. So let's go back to our page here, okay? So under the 0% vaccination, we had the observations of how they spread. We had 1 person out of 20 that was healthy, which is equal to, so if we divide 1 by 20, that's going to give you 5%. 5% of the population was healthy. All right, and if you have 19 out of 20 were sick or infected, that's going to be 95% are infected. This is with the first example of 0% vaccination. With the 50% vaccination example, we had half of the population was vaccinated, all right, and we only ended up getting 4 out of 20. We had 16 out of 20 that were healthy. All right, and I'm going to let you guys calculate the percentages of these. And on the unhealthy side, 4 out of 20 were sick or infected, which equals, I'm going to leave a blank here, what percent of infected? And this is all information that you're going to be copying down on your worksheet before you submit it. Okay, so you're going to, for each of these parts where you get your percentage of vaccination, you're going to copy down how many people stayed healthy and how many people were sick or infected with the virus. Okay, so as you're copying these things down, these different observations, all right, you can tell how much of the population is vaccinated as you change the adjust the dial. So let's go back here one more time. You're going to continue to run this. You'll hit reset. You'll continue to run this with other factors. Now I'm going to do it again with the 50% population because, the 50% of the population vaccinated, because I want to show you how the graph component of this works. So as this keeps running, remember the reset button is going to pop up here when you're all done. Okay, good. So now we can look at our button for the graphing. Well, for some reason it doesn't seem to want to work right yet. Okay, so let's keep going with these. It might only work at the end if I remember correctly. Okay, so we're going to adjust up to 80%. We'll let that run. So now most of the individuals, 16 out of 20, are vaccinated. There's only 4 that are not. Okay, so we've got our different example here. And then we're going to do our last example here, which is 95%. Okay, so you're going to go through each of these different examples, and at the end, you're going to be able to click on these graphs. And what this is showing you here is just an example, because remember, this is a simulation of what could happen if a population is being looked at for vaccination percentages and for how quickly people become infected. So this is, in this case, going to show you how quickly a virus can infect people and how quickly the numbers of infected people can go up, as well as how it changes with the different percentages of vaccinations. Finally, when you actually get done with this portion of it, I want to show you the last couple questions. So what effect did the vaccine have on the spread of measles? This is a question that always throws people off. So when you went from 0% vaccination to 50% vaccination, did that cause 50% fewer people to contract the measles? In other words, 19 out of 20 people were infected with the virus when no one was vaccinated. How many people ended up getting infected with the virus when there were 50% people vaccinated? And in other words, is that equal to half of the people who contracted it? All right, so explain why it might be different or if it is different. And then finally, did your hypothesis on the first page come true? And if it did, explain why you think it did. If it didn't, explain why you think it did not. Once you're all done with that, you'll go ahead and take a picture of both sides and submit it to Canvas. Thanks, guys. Oh, actually, one final thing. If you did not talk about the concept of herd immunity in this case, remember that herd immunity is one of the things that was discussed in your workbook, and we'll talk about it more on Wednesday. Thanks.